Hey guys, in this session I'm solving NUFYPET Math Specimen 2021, questions 6 to 10. Question number 6. We are required to evaluate the expression 32 to the power of 1/5 plus 9 to the power of 0 divided by 81 to the power 3/4 and all raised to the power -1. In this question, it's important to remember the nth power of a number. For example, 2 to the power 3 or 2 cubed is 8, 2 to the power 4 is 16, 3 to the power 4 is 81, and so on. So 32 to the power 1/5 is equivalent to the 5th root of 32, and we write 2. 9 to the power of 0 is 1, so we have 2 plus 1, over 81 to the power 3/4. To evaluate this pretty quickly, what you need to do is first to take the 4th root of 81, and that will give you 3, and then it becomes really easy to raise 3 to the power 3, right? So I'll just write here on the side that 81 to the power 3/4 is equivalent to the 4th root of 81 cubed, right? So alternatively, you can first take the 4th root of 81 and then raise this to the power of 3. So as I said, the 4th root of 81 is 3, and 3 cubed is 27. And all of that is to the power -1. 2 plus 1 is 3, 3 over 27 is 1 over 9, and the reciprocal of 1 over 9, let's write it down, is of course 9. So the answer is C. Next one, question 7. Given some quantity t, which is expressed in terms of k, h, and g, we need to rearrange the formula to make k the subject. That's actually pretty easy to do because k squared appears only in the numerator under the square root. So in order to get to the numerator, then we have to of course multiply t by the denominator. But before we do that, we need to get rid of the square root. So what I'm going to do first is to separate the square root. T over 2 pi is equal to the square root of something, and therefore I quickly can square both sides, and I've got the expression on the left hand side, which is equivalent to k squared plus h squared over gh. Okay, so we're halfway through. The next step is to get to k squared plus h squared, and this is equal to t over 2 pi all squared gh. And now of course we can subtract h squared from both sides, right? So I'm just going to get rid of h squared on the left hand side and subtract h squared on the right hand side. So k equals square root of t squared over 4 pi squared gh minus h squared. And here I have taken a positive square root because the options list only positive square roots, as you can see. I'm just going to scroll up a little bit to see which answer is correct one. So this corresponds to answer D, right? So let's circle answer D. That's the correct answer. Let's carry on. Question number 8. The sum of the roots of a quadratic equation is 7, and the product of the roots is 9. What is the equation? What is the quadratic equation? Here it's useful to remember the Vieta's formula. If we have the equation x squared plus ax plus b equals 0, for a moment we assume that the coefficient of x squared is equal to 1 because this is what the suggested options have, and if we let the roots to be x1 and x2, I missed b here. So if the roots are x1 and x2, then x1 plus x2 equals 7. and x1 times x2 equals 9. In terms of our quadratic equation, 7 corresponds to the negative a, and 9 corresponds to b. Therefore, our equation is x squared minus 7x plus 9 equals 0. The correct answer is C. So in this question, it's important to remember the Vieta's formula and also the fact that the sum of the roots is equal to negative a. This is one of the most common mistakes the students make when they use the Vieta's formula. We carry on to question number 9. A similar problem which deals with a quadratic equation, but now we have a slightly trickier condition. The roots of the equation 2x squared minus 11x plus a equals 0 differ by 2. We need to find the value of a. We have two ways of dealing with this problem. We can either use the Vieta's formula or we can use the discriminant. I would probably avoid using the Vieta's formula in this case because the sum of the roots will be 11 over 2, the product of the roots is a over 2. I don't know how complicated it may get, so I prefer not to deal with half values, so I'm going to proceed with the discriminant. So I'm going to let my roots to be x1 and x2. I'm going to write it down, but of course in the exam you don't have to do that. So let x1 and x2 be the roots of the equation. Then we know that x1 minus x2 equals 2, and it doesn't matter, you could put x2 minus x1 equals 2. So the roots of the equation are found by the formula 11 plus minus square root of 11 squared, which is 121, minus 2 times 4 times 8, minus 8a altogether. And this is divided by 4. That's 2a. 2 times 2 is 4. So what I'm going to do now, I'm going to write the difference of these two roots. So x1 minus x2 equals to 11 plus square root of the discriminant over 4 minus 11 minus square root of the discriminant over 4. And we can see that 11 and minus 11 will be cancelled out, so we end up with the 2 square root of discriminants over 4, which is equivalent to root d over 2, and this is equal to 2. Right, now I'm going to replace the discriminant by the expression that we found earlier. Root of 121 minus 8a over 2 equals 2, and therefore the square root of the discriminant equals 4. Squaring both sides gives me 121 minus 8a equals 16. 8a equals 105. And therefore a equals 105 over 8. Let's check which answer this is. This is option A. As an extra exercise, try to solve this problem by using the Vieta's formula. And the last question I'm going to cover in this video is question number 10. The longest side of a right-angled triangle is 6 plus root 5 units. One of the shorter sides is 3 plus 2 root 5 units. The question is, what is the length of the third side? Again, a pretty straightforward question if we know how to deal with right-angled triangles. Let's say A, B, C, triangle ABC. So the longest side, which in our case is the hypotenuse BC, is 6 plus root 5. One of the shorter sides is 3 plus 2 root 5. Okay, so it doesn't matter, it can be AB or AC. What is the length of the third side? What's the length of AB? By using the Pythagoras theorem, we know that AB is equal to the square root of BC squared minus AC squared. Let's do the substitution. Square root of BC squared, so we need to square 6 plus root 5, which is 36, plus 12 root 5, plus root 5 squared, which is 5, minus, in the brackets, we have the side AC squared, so 3 plus 2 root 5 squared, that's 9, plus 12 root 5, plus 4 times 5, 20. Okay, and some of the stuff will surely get cancelled out. That's 12 root 5 and minus 12 root 5. So we have 36 plus 5, 41. 41 minus 20 is 21. 21 minus 9 is root 12. And the answer that is similar to root 12 in the given options list is 2 root 3, and this is answer A.